This video is about single replacement reactions. Back when you learned how to identify if a reaction was single replacement or double replacement, you were looking for a single element plus some sort of a compound. And when we had the human analogy, it was a single person and then a couple. Well, this single person can't just displace either part. It has to replace only the part whose role it can fulfill. In this case, Angelina Jolie is a woman, so when she's going to break up this compound, this couple, what she would replace would be the woman in that relationship. So that the products would be, now that single person is not single anymore. They're in the new compound. And the one that used to be in that compound is now the new single element. So when you're looking at a real reaction like this one right here, we see that we start with a compound right here. It's made of a metal and then a polyatomic anion. And then we have the single element is a metal. Well, since it has to replace the part whose role it can fulfill, zinc is going to have to replace silver. Silver is the one that's going to have to go away and be the new single element. So over here on the product side, we see that silver, the metal, is now by itself, and our new compound has what used to be our single zinc in the compound with the same anion. Now notice that before, nitrate was not in parentheses, did not have a 2 outside, but in the products it does. That's perfectly okay. Silver has a positive 1 oxidation state. Nitrate is always negative 1. Well, zinc has a positive 2 oxidation state, so it's going to need 2 of these nitrates. It doesn't matter, like, you don't have to worry about the 2. We write the formulas based on what's pairing with each other, and in this case, the zinc is what's going to pair with the nitrate. But the lone element is not always a metal. It could be a non-metal, like in this case down here, where chlorine gas is our single element. Remember that chlorine is a diatomic element, so it's in Brinkelhoff, it's got a little 2 there. We have an ionic compound, potassium's a metal, iodine's a non-metal. Well, we can't have chlorine partner up with iodine and displace potassium. It has to replace the element whose role it can fill. This is an ionic compound. To keep it an ionic compound, chlorine has to displace the other non-metal. So that puts iodine out as our new single element, non-metal, also a diatomic, so it needs a 2 there. And then chlorine becomes the non-metal in the ionic compound with potassium. It was diatomic here because chlorine can never be alone, so if you just have single element chlorine, it's in pairs. But here there is no 2 because potassium has a positive 1 charge, chlorine has a negative 1 charge in ionic compounds. They cancel each other out and there's no need for any numbers.